Okay, dear students, welcome to the class. I am taking the class of HVAC. As the instruction is to do the taking of the class on online, you are requested to be present in the class. Put your attendance in the online sheets. That means you have to put your attendance in the group. You have to write your roll number in the group, in the WhatsApp group, I mean to say. Whoever present here, that will be marked. Attendance is mandatory for all the students of 8th semester who have taken HVAC. Now we'll be talking about chilled water and condenser water system today. Chilled water and condenser water system today. There is a piping layout with boiler. So I'll be drawing that in the diagram. Just follow me in the diagram process. Just see the diagram, what I am drawing, and then I'll explain it. Just follow the diagram I am drawing. See it minutely. I'll be talking about the diagram after drawing it completely. Now this shows the whole diagram. This is the chilled water, condenser water, not condenser water, chilled water, hot water schematic diagram. You can see through the whole picture. There are two number of chilling machines. These are indicated as CH1 and CH2. CH means chilling machine. Now, chilling machine, as I already told in the earlier classes, has got two systems. One is chilled water system, another is condensed water system. Chilled water system passes chilled water from the chilling machine to different AHUs, air handling units and fan coil units, which are supplying cold air to the room. Cold air comes as the air passes through the chilled water within the chilled water system. This has been already explained to you with AHU diagram and such other things. So you can see in this diagram, I am showing you the chilled water system. This is the chiller 1, chiller 2, along with the boiler. The boiler provides with the hot water. That's the hot water system. That's done during winter season. There is a small change in that. I have not marked it. This is winter on. This is summer on. This one summer on, this is winter on. Now I'll tell you how they will work. Now these are in parallel arrangement. Chilled water, chiller 1, chiller 2 and boiler. Each chiller and boiler has got one pump before that. These are chilled water pumps. This is boiler pump. Now, chilled water pump passes chilled water through the chilling machine. The water enters the chilling machine at a temperature of 54 degree Fahrenheit, and it leaves the chilling machine at a temperature of 44 degree Fahrenheit. That means this temperature of water going is 44 degree Fahrenheit. This temperature of water coming is 54 degree Fahrenheit. Remember, it is Fahrenheit, not degree centigrade. This is how the chilled water system is going on through the network of the buildings. These are different floors of the buildings. These are different floors of the buildings. I can tell it ground floor. This I can tell as first floor. This I can tell as second floor. And then there is terrace. This is terrace. And there is one expansion tank. Here is one expansion tank. Now, what happens? The chiller pumps the hot water at 54 degree Fahrenheit to the chilling machine. It gets cooled to 44 degree Fahrenheit. 44 degree Fahrenheit comes like that through this path, comes like that. And from here, it supplies to different HUs and FCUs. You can see the diagram. See the direction of the arrows mark. This is the direction of the arrows mark. The water is flowing like this and supplying to the HUs and then FCUs. You know HUs, air handling units, and you know FCUs, fan coil units. Air handling units are floor mounted, supplies air to the whole building. I already described air handling unit in my earlier classes. Fan coil units are the units which supply in the cabins or hotel rooms or such other individual setups like classrooms. So these are different air handling units and fan coil units being arranged here. This is the way chilled water goes, supplies to the HU. It enters the HU at a temperature of 44 degree Fahrenheit. Remember, this is coming at 44 degree Fahrenheit. This is coming at 44 degree Fahrenheit. After enters at 44 degree Fahrenheit and goes out at 54 degree Fahrenheit. This is coming back at 54 degree Fahrenheit. This is coming back at 54 degree Fahrenheit. See, it is 54 degree Fahrenheit. At 54 degree Fahrenheit, it comes in chilled water, takes a delta T of 10 degree, drop, goes at 44 and again comes back. Same delta T, 10 degree, rising in the HU. Why it is rising in the HU? Because hot air is going through the HU. That hot air gets cooled by chilled water at 44 degree centigrade, 44 degree Fahrenheit, and the chilled water gets heated up, taking that heat to 54 degree Fahrenheit, and hot air gets cold, and this cold air is supplied to the system of the room. You should understand that this temperature delta T of 10 degree Fahrenheit maintaining is very, very important. If instead of 54 degree it becomes 53 degree Fahrenheit, the temperature system will collapse. That we cannot do. That's why we have to take at a temperature of 54 degree Fahrenheit only, which is going out and from the HUs and going to chilling machine at 54 degree Fahrenheit, comes out at 44 degree Fahrenheit. Now this temperature is fixed of delta T. This gives a delta T of 10 degree Fahrenheit. Try to understand. There is a simple mathematics in that. The calculation I have shown you in the other earlier classes, where it is taken as 2.4 GPM per ton How the calculation is, I have shown you in the earlier class. 2.4 GPM per ton, delta T, it becomes that. This GPM or gallons per minute comes out through the pipes, and the pipe sizes are determined according to the gallons per minute. You should understand that. That's what is very important. This pipe size is determined on the basis of the gallons per minute of water flowing. That means as the pipe is going here, the initial pipe size is highest as it is supplying the whole line. But as it goes, it starts distributing to the HUs, water quantity gets less, GPM gets less, so the diameter decreases. In case of this, as it goes through the chilled water pipeline, is the main pipe holding the highest amount of gallons per minute. The gallons per minute is determined by 2.4 GPM per ton. If it is a 100 ton machine, then 240. It becomes, if it's a 100 ton machine, then 240 GPM is passing through this. Then this pipe will be designed at 240 GPM. 240 GPM, the corresponding diameter will be seen through a chart, closed water pipe chart, and accordingly this diameter will be determined. And then it comes through this, goes like that and supplies to the HUs again. You can see at the top of this, at the terrace, there is an expansion tank. Now what is the function of the expansion tank? Why expansion tank is here? The expansion tank is here because in the expansion tank, if there is a temperature rise of 44 to 54 degree Fahrenheit, the 10 degree Fahrenheit, there is expansion of water because of the temperature gain. You know, whenever there is gain in temperature, there is expansion of substance. And water, being a fluid substance, also undergoes change in volume because of high temperature. When the volume of water increases, there is a chance of water to come out, but it cannot come out unless I give an outlet for it. So I have given an outlet through the expansion tank. It comes to the expansion tank, and here